Our next presenter is Rakesh Rayapureddi. He's from Shiv Nadar University. His topic today is fully electric and autonomous paddy stubble harvester. So over to you, Mr. Rakesh.
Thank you. So my name is Rakesh from Srinagar University. I graduated in 2020, and since then I'm working on a novel solution for stubble burning problem in Delhi NCR region. Uh, Along with me, I have Vaibhav Saigal. He graduated in 2020 from mechanical engineering, 2021 from mechanical engineering, and we both are going to do the presentation today. Yeah. Today we're going to present about our fully electric and autonomous paddy stubble reaper baler. So many of us are aware of this stubble burning problem, which is leading to a huge air pollution and severe lung problems to many people, affecting staying in the affecting regions. So let me explain why the problem is happening. So this problem basically occurs due to the heavy dependence on traditional machines and huge heavy investment and less reward and less time gap for the farmers. Uh, okay, so the background of this problem is presented in this slide. So on the left, you can see uh, a combined harvester harvesting the paddy crop after the okay. So here we can see the stubble that is left on the field, and the farmer would require the land for seeding in a 15 days time period. So the conventional way farmer has to do is he. Am I audible? Yeah. So the conventional way for the farmer to get his land done is he should use the stubble shaver, straw rake, and straw baler. Or likely the farmer are preferring to burn the crop and getting his land ready for the seeding. So here we are proposing a single shot solution that can directly help the farmer to get his land prepared in a less time. Yeah. Okay. So the these are the combined machineries that are available in the farmlands. Okay, so the problems. So here we have developed a novel cutting mechanism that can help the farmer to cut the stubble from the ground level. So the reason behind what are the applications of this paddy stubble? So after harvesting the paddy stubble, it can be used in many other applications such as biomass industries, pellets, or even it can be used as a replacement for construction materials, cattle feed. So the problem lies here is how to get the stubble from the farmland to industries where it can be processed to use for all this application in a less time window. So the idea behind our invention is a integrated machine that can do all the three individual tasks: the cutting, the collecting, and making it into easy to transport bales. So this is a machine that we have developed, and we have patented the method for making the bales. This has shown proven its advantage in many other aspects. The conventional balers has many mechanical drawbacks which the farmer are not use that. So we have developed a unique bale making mechanism that addresses all these problems. So and another important key feature of the machine is the autonomous feature. So the machine can be driven in a farmland on its own. So the farmer has to fit the location of this farmland. So the machine has its path planning, perception, and response to the obstacles. So this is a framework of the algorithm. So we are using LiDAR along with the GPS and IMU sensors for localizing the machine, and we are using the the register nano for making the for processing the data. So here we are presenting a small example here for the path planning. So once the farmer has selected his farm location based upon from the digital uh, UI given to him, the algorithm will generate a spiral path in the farmland. So here is an example. We have selected the 4 coordinates on the land. You can see on the left, and the farmer and the algorithm generates a spiral path here. So this is an example. This is a cricket ground that we have in a college, and we have selected the four sorry 6 coordinates of it. So this is a path generated. So once the path is generated, the machine will be driven in in this path on its own. And the other challenges here is the obstacles. So for avoiding the obstacles, we are using computer vision. So we have trained the model. So here is an example. So we have compared the like differentiated between the person and the any animal. So here is one more example. We can see on the image the farmer and the tractor separatedly. And in the bottom image, we can see the person and the animal separately. So these are the images that we have trained used for the training of this algorithm. So we have completed the path planning and the perception of this machine. So now for the response to generate the machine to move in the given selected path. So the machine has equipped with the high torque BLDC motors. So along with my motor controller. So the path generated will be loaded into the motor controller, and the machine will be driven in the path accordingly. So this is a design of this machine. The machine includes cutter, a conveyor, and a bale chamber. So once the stubble is cut, it will be transferred to the bale chamber via conveyor, and we are having a control unit in the front of it. So the control unit will be powered using the solar panels mounted on the top of it. So this is a unique cutter design that we have developed. So the advantage of this cutter is the stubble can be harvested from the ground level, leaving around 2 inches gap, which is required by the farmer. So this is the design of it. So once it is cut, it is transferred to the conveyor attached to it. So these are the current progress. So we have developed a prototype of this machine, and we have done some primary testing. So the vision of us is to be to reach a goal of serving farmers using technology and feed the growing population. This is our team. So Vaibhav, uh, he graduated in 2021, and he has a 2 years experience, industry experience. And myself, Rakesh, and we have robotics control engineer Amit. And here are the advisors: Dr. Ankit Gupta, he's a design advisor, and Dr. Shantram Mitra, he's a robotics professor, and Dr. Jyotika Sharma, he's a professor and has 50 years experience in environmental engineering. So we are backed by the Shiv University. The complete project has been funded and supported by the university, and we also received recognition from Niti Aayog for making this into a wide scale and to launch into the market. And we received a technical support from Altair for doing the simulations and finding uh, the functionality of this machine. Okay, thank you. And before concluding, currently we extended this project to the stubble managing ecosystem, which includes after harvesting the bales, the bales are converted into a small, tightly packed pellets in the farmland itself. So for that ecosystem, we are currently working on uh, a bot that can help to collect the randomly fallen bales and take it collect and place it into a dock station in the farmland where it can be easily converted into any other form of it. Thank you. If you have any questions, feel free to ask.
Hello,
Thank you,
Rakesh.
Rakesh, for your nice presentation. So I'll request if from audience, if you have any question, you can raise.
Hello, Rakesh. Mahendra here. Actually, I have three couple of questions.
Yeah, sure.
One is that regarding means this path planning and that navigation. You have used the GPS here,
Right,
but
right.
in GPS that location accuracy is means 1 to 2 meter. So to
Right, right.
means reduce that, which kind of alternative system you have used to means minimize the error, means location error?
Right. So actually, sole GPS cannot be used for making this path. Actually, yeah, you are right. The GPS has this 2 meter of error, to make 2 meter of accuracy. So to avoid that, we are using multiple sensors data like IMU and computer vision. We are fusing all these three data using Kalman filter and filtering the error and achieving this kind of path.
Okay, means suppose GPS, if GPS is not working, then still your system will be able to navigate, or means
Right, right. So GPS should work when the farmer has to load the coordinates. Here we can see the coordinates, right? So farmer initially has to feed the coordinates. So once it is generated the path, the machine can be navigated using the computer, the camera and the wheel encoders itself. So it doesn't require the GPS later on, but initially yeah, it required to be working condition.
and that inside you have generated many paths, concentric paths. For what?
Right.
For that, what kind of algorithm you have used?
This path generation information has been like I cannot disclose that right now. So this is still in progress now. So yeah, this information cannot be disclosed right now in this point at this point. So actually, we are in the process of filing a patent for that. So yeah, we would be more than happy once to share this information once we are like legally
Okay, okay.
recommended to do that.
Yeah, one more means yeah, okay. Can you go to the last slide just before the last slide?
One second.
Okay. So means what would be the what would be the dimension of this, means in terms of actually I am not able to visualize, means what would be the size of this
Yeah,
system?
I can show a video here. Video of our testing. This is. Can you see my screen here?
Yes, yes.
Yeah. So let me show this video. Here the size prototype. So this is the initial testing and we see a lot of vibrations in this mission. So now we have rectified that. So this is currently tested using the remote and the GPS.
Okay, okay. So you have used the BLDC motors, na hub motors, BLDC hub motors.
Right.
Okay, okay. And so what will be the approximate cost of this system if anyone was to procure?
So this prototype has been using 1.5 lakh, but once we are planning to launch, when we are planning to launch in the market, we are trying to approach government and provide subsidies over it, and then we can bring the cost further low.
Okay, okay, okay. Understood. Thank you, Rakesh.
Yeah, thank you.
So from audience, okay, Aniruddha, I have some question, please.
I'm sorry, just one short question. Hi, Rakesh. That was a wonderful
Hi, Aniruddha. Yeah.
presentation. So, like, I just want to have an idea of, like, since this proposition is for stubble bonding, so
Right.
what is the actual capacity of stubble it can remove over a time? Like, did you try it with the stubble? Because the stubble is a very hard thing, right? So,
Right.
how much volume it can remove in an hour or like in a minute?
So for the this prototype, so that we have a selected data. It is calculated that on an average, the 1 hectare of land consists around 4-5 tons of stubble. So the machine can harvest one hectare of land in around 90 minutes, 80 to 90 minutes. So, and we are achieving almost 80% rate of the harvesting. So accordingly, we can calculate the amount of stubble that we can harvest. So that is around coming to be around 300 3 tons of stubble that can be conducted from hectare for every 90 minutes.
Thank you. Thank you. Thank you for that.
I have one short question. Can I?
Yes, sir. Yeah, sure.
Yeah, Rakesh, I'm having one question. What kind of electronic and computation hardware you have used?
Electronic hardware we are using Jetson Nano for the micro for the control unit part, and for electrical part we're using the 2 kilowatt BLDC motors. So this is, you can see, a skid steering mechanism. So the steering will be done using like as a replica of the army tankers. So let me show the image. Yeah.
Your voice was breaking. So
And
it is
rest
Jetson
we are
Nano you
using,
specified.
sorry, yeah, it's just
So one single
along
Jetson
with,
Nano can work for the whole system.
right. It can work. We are using Jetson Nano for the the path control of the machine. Rest we are using the for the internal electronics we are using Arduino Mega.
Okay, so there is no vision based system.
No, we have vision based system. We are using Jetson Nano and the stereo depth camera for finding the obstacles and calculating and rectifying the path accordingly.
And which part of the country you are testing this prototype?
In North India, like we are planning to take this. We are currently in Noida, so Uttar Pradesh, and but the major problem of the stubble burning is happening in Punjab. So we are going to take the machine and demonstrate in Punjab soon.
Okay,
The
okay,
target we are
thank
planning to test it, demonstrate it in this coming stubble harvesting season, stubble burning season. Sorry, it's in November.
So your company is based in Delhi.
Right.
Okay, okay. Thank you very much, Rakesh.
Thank you, sir.
Okay, thank you for the nice presentation, Rakesh.